predator's tooth buried inside living bone, a compound eye torn open on the floor of an ancient sea, a hole longer than your hand punched clean through a skull. Each of these injuries should have been a death sentence. But every animal you were about to meet survived, and their skeletons kept the receipts. Healed bone is the only kind of fossil damage that proves an animal was alive to feel it. So tonight we are reading 5 medical charts written in stone, and the oldest patient on the list checked in nearly 500 million years ago. Before we open the first chart, you need to know how a skeleton writes its own survival story, because this is the trick that makes everything else in this video possible. Paleontologists find damaged fossils constantly. Bones get crushed under sediment, gnawed by scavengers, snapped by 90 million years of geology grinding overhead. Almost all of that damage is noise. A bone broken after death shows clean, sharp edges and nothing else, because dead tissue cannot respond to anything. A living skeleton is a different machine entirely, because bone is alive. It is tissue like any other, threaded with blood vessels and packed with cells that spend their days tearing down old material and laying down new. Break a bone in a living animal, and within days a blood clot forms. Within weeks, a lumpy callus of fast, disorganized tissue called woven bone bridges the gap, and over months that rough patch gets remodeled into smooth, ordered, load-bearing bone. Every stage looks different under a microscope, which means every healed injury in the fossil record is a biological timestamp. It tells you the animal survived the event and roughly how long it lived afterward. Doctors reading an X-ray of your old broken arm can estimate when you broke it from the state of the callus. Paleontologists run the same clock on animals dead for 66 million years, or 465 million, and the clock still reads. There is a name for this discipline: paleopathology, the study of ancient injury and disease, and it is nearly as old as dinosaur science itself. One of its founders, an American anatomist named Roy Moody, was cataloguing tumors, fractures, and infections in fossil bone back in the 1920s, squinting at Ice Age hips and Jurassic vertebrae decades before anyone had a hospital scanner to point at them. Keep his name in your pocket, because Moody returns at the end of this video, when one of his own diagnoses gets overturned after standing for 90 years. Death tells you how an animal ended. Healing tells you how it lived. And here is the part that should raise the hairs on your arms. Every case in this video is a survivor, and every survival forced scientists to rewrite something about the animal's biology or its behavior. An immune system older than jaws and forests. A dinosaur that shrugged off injuries that would put you in intensive care for months. Combat proven under a microscope. Maybe even compassion. All of it written in scar tissue. So let's meet the oldest patient on Earth. 465 million years ago, the seafloor of the Ordovician period was a dangerous neighborhood. Forget everything familiar. There were no trees anywhere on the planet. There were no animals on land at all. Fish existed, but they were small, armored and jawless, sucking food off the bottom like living vacuum cleaners. The top predators of these seas were cephalopods, relatives of today's squid and octopus, some of them riding inside straight, cone-shaped shells that could stretch longer than a canoe, armed with grasping arms and a hard, parrot-like beak. Crawling below them in astonishing numbers were the trilobites, armored arthropods that looked like a cross between a horseshoe crab and a pillbug. One of those trilobites, pulled from Ordovician rock in southern Norway, is the oldest confirmed patient in the fossil record. Its case was published in the journal Scientific Reports in 2017 by a team including Bridget Schoenemann, pronounced roughly Scher-Neumann, and the veteran trilobite specialist Ewan Clarkson. What they found under high magnification was gruesome and beautiful at the same time. The animal's compound eye, a dome built from dozens of crystalline lenses, had been ruptured, torn open. One quick word about that eye, because trilobite eyes deserve a documentary of their own. The lenses were made of calcite, the same mineral that builds limestone, grown as clear, precisely oriented crystals. These animals were, in the most literal sense, watching the world through polished stone. It ranks among the strangest solutions to vision ever evolved, and it fossilizes beautifully. which is the only reason tonight's oldest story can be told at all. The most likely culprit, according to the researchers, was a cephalopod attack, that hard beat punching through the one part of a trilobite that cannot be armored, because an eye has to stay transparent to work. That should have been the end. An open gash in the Ordovician ocean, swarming with bacteria and scavengers, on an animal with no bones, no jaws, and a brain smaller than a grain of rice. Instead, the fossil preserves the repair. A smooth, clot-like seal caps the damaged region, startlingly similar to the way wounds close in living arthropods today. The broken plates of the exoskeleton fused back together. Inside the rebuilt eye itself, new visual units had grown in, irregular, crooked, jammed in at odd angles. But there, the eye was patched, resealed, and partially rewired. This little animal took a beak through the eye from the reigning killer of its era and grew the eye back. Think about what that requires: wound recognition, clotting, infection control, and tissue regeneration, all working in sequence. That is a full immune and repair system up and running on a creature that lived before jaws evolved, before trees existed, before anything with legs had ever touched dry land. Your own immune system was never a mammal age invention. You inherited it from something like this, 500 million years deep and already battle-tested. And there is one more detail in this fossil, the kind of detail that separates a good story from a great one. The specimen preserved in that Norwegian rock was never the animal's corpse at all. What survived is a molted shell. Trilobites, like crabs and insects, shed their exoskeletons as they grew, which means this animal healed the wound, kept living, kept eating, and eventually crawled out of its own repaired armor and walked away, leaving the evidence behind like a discarded bandage. Molting, for an arthropod, is the single most dangerous routine act of its life. The animal splits its old armor, drags itself out soft and defenseless, and waits, exposed, while the new shell hardens. Doing that with a half-repaired eye, in a sea patrolled by shelled hunters the length of canoes, and surviving it, is a second small miracle stacked on top of the first. The victim itself moved on. What we hold is proof of the recovery. Nor is this trilobite alone. Trilobite shells preserve healed injuries across roughly 250 million years of their existence, one of the longest injury records of any animal group ever. Healed bite marks show up on Cambrian species even older than our Norwegian patient, on Elrathea kingii, pronounced Elrathea kingii, from the deserts of Utah, and on Redlickia, pronounced Redlickia, from the Emu Bay Shale of South Australia, rocks more than 500 million years old. Every one of those crescent-shaped healed bites is a failed murder, which makes botched predator attacks some of the oldest recorded behavior in the entire history of animal life. The fossil record's oldest stories, it turns out, are survival stories, and the next survivor on our list makes this trilobite look like it got off easy. Jump forward about 315 million years to the floodplains of late Jurassic Wyoming, 150 million years ago. In 1991, a Swiss fossil crew working the Badlands of the Howe Ranch near the town of Shell in Bighorn County spotted bone weathering out of the Morrison Formation. Because the skeleton lay on public land, excavation fell to the Museum of the Rockies and the University of Wyoming, and what they uncovered became one of the best-known dinosaurs ever found. A young Allosaurus, about 26 feet long, roughly 87% grown, and about 95% complete, lying almost exactly as it died. The crews nicknamed it Big Al, and in 2020 it was reclassified as its own species, Allosaurus jimmadseni, pronounced Jimmadsen-I. Allosaurus was the apex predator of its world, the lion of the Jurassic, a two-legged hunter with a mouthful of steak knives. And Big Al's skeleton reads like the case file of a boxer who never learned to duck. To be fair, the neighborhood invited it. The Morrison Formation is a running catalogue of Jurassic violence. Paleontologist Kenneth Carpenter, a name that returns later tonight, described an Allosaurus tail vertebrae with a partially healed puncture wound that fits the tail spike of a Stegosaurus the way a key fits a lock. So at least one Allosaurus picked a fight with dinner that fought back, took a spike for it, and lived to limp away from that too. Life at the top of the Jurassic food chain came with a dental plan and no health insurance. When paleontologist Rebecca Hanna published the full pathology workup in the Journal of Vertebrate Paleontology, the count came to at least 19 separate injuries and infections spread across the body. 5 broken ribs, some showing the kind of incomplete fracture doctors call a willow break, the injury you get from blunt impact rather than a fall. A fractured shoulder blade, damaged vertebrae in the neck, back, and tail, a broken bone in the hand, a hole punched clean through the ilium, the big plate of the hip, apparently from a blow driven in from above. 2 damaged foot bones. Worst of all, an infection called osteomyelitis, pronounced osteomyelitis, raging through the toes of the right foot. On the first bone of the third toe, the infection had swollen the bone into a grotesque bulbous mass, and around the dying tissue Big Al's body had grown a sleeve of new bone called an involucrum, pronounced involucrum, a biological containment wall, the skeleton's version of quarantining a fire. Here is what stunned the researchers. Nearly every traumatic injury on this animal shows healing. The ribs knitted, the shoulder blade fused, the hip repaired itself around its puncture. This predator walked off collisions and falls and blows that would hospitalize you for a season, over and over, for years. Even more telling, the fractures on the left shoulder blade and the left ribs line up, which suggests a single violent event, one very bad day that Big Al ate whole and survived. And Big Al is not even the only one. In 1996, a few hundred meters away on the same ranch, another crew dug up a second Battered Allosaurus, promptly nicknamed Big Al 2. When researchers reviewed its injuries, they found that with the single exception of a broken ischium, pronounced ischium, one of the lower hip bones, every traumatic injury on Big Al 2 shows unambiguous evidence of healing. 2 apex predators, same neighborhood, both carrying catalogues of survived damage. That pattern raises an uncomfortable question for the lone hunter image of Allosaurus. Some researchers have proposed that an animal repeatedly crippled this badly, unable to sprint or grapple for weeks at a time, might have survived those recovery windows because it was not always alone. That idea is a hypothesis, not a verdict. And plenty of paleontologists would tell you a big meat-eater can limp along on carrion and luck. But the injuries force the question, and unbroken skeletons never would have asked it. As for Big Al's ending, the evidence points somewhere grimly specific. The traumatic injuries healed, the foot infection did not. Osteomyelitis in a toe sounds almost comical until you remember what this animal was. A pursuit predator earns every meal with its feet. Every step on that swollen, throbbing toe was agony, and every hunt demanded thousands of steps. The skeleton was found lying in an ancient stream channel, and however the final day unfolded, the sickness in that right foot had been starving the hunter for months. Big Al became a household name in 2000, when the makers of Walking with Dinosaurs built an entire special around this one skeleton, The Ballad of Big Al, reconstructing the life behind the injuries for millions of viewers, ending with the young hunter dying of thirst in a dry riverbed, hobbled and spent. The drought scene was a dramatization, an educated guess. The foot was never a guess. Big Al survived everything the Jurassic threw at him except a germ. If that feels like a gut punch, hold on, because the next case involves the most famous predator that ever lived, and the dinner that got away. For decades, paleontology carried on a surprisingly heated argument about Tyrannosaurus rex. The animal's reputation says relentless hunter. But a camp of respected scientists looked at the evidence and saw something less flattering. Tiny arms that could not grasp prey. Enormous olfactory chambers, the anatomy of an animal built to smell rot from miles away. Maybe, they argued, the tyrant king was a scavenger, a 7-ton vulture waddling from carcass to carcass. The loudest version of that argument came from Jack Horner, one of the most famous paleontologists alive and the scientific advisor behind the Jurassic Park films, which gave the fight a delicious irony. The man who helped put the roaring movie monster on screen spent years arguing that the real animal mostly ate leftovers. Museums staged public debates about it. Documentaries picked sides. The idea drove dinosaur fans crazy, and for years nobody could settle it, because a bite mark on a fossil cannot tell you whether the victim was alive when the teeth went in. A T-Rex gnawing a carcass leaves the same punctures as a T-Rex committing attempted murder. To prove predation, you would need something absurd. You would need a victim that got bitten by Tyrannosaurus rex and escaped, carrying dated, signed evidence of the attack in its own body. In 2007, a graduate student named Robert De Palma, pronounced Do Palmu, found exactly that in the Hell Creek Badlands of South Dakota. He was excavating hadrosaur bones, the duck-billed plant-eaters that moved across that landscape in herds, when he spotted two tail vertebrae fused together by a mass of lumpy pathological bone growth. He brought the mass to paleontologist David Burnham at the University of Kansas. They cleaned it, and sitting inside the overgrown bone was a tooth. The team drove the specimen to Lawrence Memorial Hospital in Kansas and ran it through a hospital scanner, and the images showed the crown of a large theropod tooth, about 1.5 inches long, snapped off deep between the two vertebrae, with healed bone grown completely around it. The serrations on that crown, counted and measured, matched one animal in that ecosystem. Tyrannosaurus rex, probably a not quite fully grown one. The team published in the Proceedings of the National Academy of Sciences in July of 2013, and the logic of the paper is a closed door. Dead animals do not heal. You do not bite a corpse and leave your tooth sealed inside growing bone. The only way this fossil can exist is if a living hadrosaur, most likely Edmontosaurus annectens, pronounced Edmontosaurus annectens, was attacked by a living Tyrannosaurus rex, tore itself free with a broken tooth lodged in its tail, outran the most feared carnivore in Earth's history, and healed. The injury closed over the tooth like an oyster coating a grain of sand, and the animal may have lived for years afterward, entombing the evidence until a graduate student pried it out 66 million years on. One fossil, and the scavenger-only hypothesis was effectively finished. Not because T-Rex never scavenged. It almost certainly did both, the way lions and hyenas do today. But Hunter is now proven on the record, with a tooth for a signature. And how does a plant-eater escape a Tyrannosaurus rex whose jaws have already reached its tail? The bite landed low on the tail, far from anything vital, which suggests the hadrosaur was already at a dead run, the predator lunging at the last piece of dinner leaving the room. One more tail length, and this fossil never exists. The beautiful part is that this Edmontosaurus is not even unique. Walk into the Denver Museum of Nature and Science, and you can see a mounted Edmontosaurus with a healed U-shaped bite sheared off the tops of its tail vertebrae, a chunk of tail just gone, the spines regrown smooth and rounded, an injury paleontologist Kenneth Carpenter matched to the gape of a tyrannosaur mouth. Same year as the tooth paper, 2013, researchers described yet another Edmontosaurus, this one bitten in the face. The fossil preserves healed bone near the right eye socket and the drag marks of teeth raked across the skull. And because Edmontosaurus fossils sometimes preserve skin impressions, this one kept something no dinosaur had ever shown before, a fossilized patch of scarred skin above the wound, its scale pattern disrupted and healed over, the first clear healed skin wound known in any dinosaur. A scar, in the everyday sense your own body understands. The takeaway is almost funny. The most famous predator in history has a documented record of biting a large herbivorous duck-faced salad enthusiast and losing. Repeatedly. Hadrosaurs had no horns, no clubs, no armor. What they apparently had was speed, herdmates, and a punishing amount of muscle in that tail. 66 million years later, the receipts are still healing. If you are enjoying this so far, take 1 second and subscribe. This channel digs through deep time for verified stories exactly like these, and there are far more fossils in the drawers than we can fit in one video. Now, from the dinner that escaped the king to two giants settling a score face to face, because the next chart belongs to a fighter and it took a microscope to prove the fight happened. In May of 2014, commercial fossil hunter Walter Stein was prospecting a ranch in the Hell Creek Formation of South Dakota when he found the first bones of the largest Triceratops known to science. The skeleton, restored over years in a specialist workshop in Trieste, Italy, stands with a skull over 8 feet long. In October of 2021, it sold at auction in Paris for $7.7 million to a private buyer, one of the highest prices ever paid for a fossil, to the open dismay of scientists who watched a record-setting specimen vanish into private hands. Along the way, it picked up a fittingly heavyweight nickname, Big John, and quick footnote for the detail lovers. The scientific paper on Big John originally listed the discovery site as Montana, and the journal later published a formal correction moving it to South Dakota, which tells you the fact-checking in this field cuts both ways, and even the professionals issue corrections in public. But Big John's price tag is not why he belongs in this video. His injury is, on the right squamosal, pronounced squamosal, one of the paired bones that form that iconic frill. There is an opening punched straight through shaped like a keyhole, roughly 8 inches long and 2 inches wide. For scale, that squamosal bone alone runs nearly 4 feet from end to end, a single plate of skull armor longer than a bathtub. For decades, holes like this in ceratopsian frills sat at the center of a genuine scientific argument. One camp rid them as battle damage from the horns of rival Triceratops. The other camp pointed out that some ceratopsians grew natural openings in their frills to save weight, so a hole proves nothing by itself. And the doubters had a fair point. Tyrannosaurus, a close cousin from the same time and place, carried enormous natural windows in its frill as standard factory equipment, no combat required. A gap in bone, on its own, is just a gap. The frill as armor story, the dueling Triceratops of every childhood dinosaur book, remained an assumption wearing a lab coat. Settling it required doing to Big John what a coroner does to a suspicious body. In 2022, a team led by regrew pronounced D'Anastasio, an Italian researcher who normally studies disease in ancient human remains, published the microscopic workup in scientific reports. They sampled the bone rimming the keyhole and put it under the lens, and the tissue confessed. The margin of the hole was ringed with plaque-like deposits of reactive bone, the signature of periostitis, an inflammation response. The bone closest to the opening was porous and dense with blood vessel channels, meaning it was newly formed, freshly built woven bone. Scattered through it were microscopic resorption pits called Hauschip lacunae, pronounced Hauschip lacunae, the tiny bite marks left by cells that demolish bone during remodeling. Inflammation, new construction, and active renovation, all at once. That combination has exactly one meaning. This hole was a wound, and at the moment Big John died, that wound was in the middle of healing, the tissue even knitted in a fashion the team compared to the way mammal bone heals, faster and more aggressive than the sluggish repair you would expect from a modern reptile. From the shape and angle of the opening, widest toward the rear and punched from behind, the researchers reconstructed the blow itself, a horn driven into the back of the frill, most plausibly by another Triceratops, and they even tested the geometry against a cast of a Triceratops horn to confirm the fit. Based on how far the healing had progressed, the fight happened roughly 6 months before Big John died, and he did not die of it. Something else took him down later, with the frill still under repair. Roll that around for a second. 2 animals the size of delivery trucks, each carrying 3-foot horns on a 6-ton chassis, squared off in the closing act of the Cretaceous, and one drove a horn through the other's skull shield, and the victim walked away and healed for half a year. This is the first time microscope-level tissue evidence has proven that Triceratops fought its own kind. The frill did more than advertise for mates. On at least one Tuesday in the Cretaceous, it served as armor, and the armor worked. The fossil record almost never hands you a fight. Bones do not preserve motive, but healing preserves timing, and timing turns a hole into a story. Which brings us to the final patient, and the one case in tonight's file where the injury was never survivable alone. Come forward 65 million years and change, to a patch of Los Angeles where black asphalt still bubbles up through the grass beside Wilshire Boulevard. The La Brea tar pits have yielded millions of Ice Age bones, and no animal defines the collection like Smilodon fatalis, pronounced Smilodon fatalis, the saber-toothed cat, 7-inch canines, the body of a bear-sized wrestler, the official state fossil of California. The tar pit collections are famous among paleopathologists for a particular reason too. Thousands of Smilodon bones show healed damage, crushed chests, broken legs, battered spines, the kinds of trauma that would sideline any hunter for months. and the sheer number of survivors has fed a food-sharing argument for the better part of a century. Among those millions of bones sits the strangest entry in that ledger, a pelvis, catalogue number 131 in the museum's Hancock collection. And it is a wreck. The right hip socket is destroyed, deformed, flared out of shape, the joint surface eaten away. In 1930, the pioneering paleopathologist Roy Moody examined it and delivered the obvious diagnosis. Massive trauma, followed by infection. A hunting accident. Maybe a kick from a horse or a bison that shattered the hip and festered. For nearly a century, that verdict stood in the files. Then, in 2021, researchers at La Brea did something nobody had bothered to try. They teamed up with orthopedic surgeons at Cedars-Sinai, the people who rebuild human hips for a living, and ran the pelvis and its matching thigh bone through a hospital scanner. The study, led by paleontologist Marin Bellisi and published in Scientific Reports, overturned 90 years of assumption. The socket was not smashed. It had never formed correctly in the first place. The scans showed a socket too shallow and oval where it should be deep and round, with the internal bone structure of a joint that had been remodeling abnormally since birth. The diagnosis, confirmed by the same surgeons who see it in living patients, was congenital hip dysplasia, the exact condition that afflicts German shepherds, house cats, and human beings today, which transforms this from an injury story into something stranger. This cat was born broken. The deformity meant the right hind leg could never bear full load, and everything about how Smilodon made a living ran through the hindquarters. This was an ambush predator, built to grapple bison and young mammoths to the ground with raw power before using those sabers. The study's authors are blunt about it. An animal with this hip could not have hunted properly, and could not have defended territory on its own. It should have starved as a juvenile. Instead, the bone tells us it reached full adulthood, because the pelvis is completely fused and full adult size. Something kept a non-hunting saber-toothed cat fed and protected for years. The study's stated most likely explanation is the one that rearranges how you picture these animals. A social group, a pride, or something like one that hunted while this cat could not, and let it eat anyway. And honesty requires the asterisk. So here it is on the record. Whether Smilodon lived socially is still an active scientific debate. The tar pits trapped huge numbers of Smilodon, which some read as evidence of pack behavior. But golden eagles pile up in those same deposits, and nobody thinks eagles hunted in wolf packs. A dying animal bellowing in the asphalt would draw solitary carnivores too. The dysplasia paper presents social care as the best available interpretation of this bone, not a settled fact, and that is exactly how you should hold it. But sit that skeleton next to the alternatives and the pull of the idea is hard to escape. However it happened, a crippled predator that could never hunt survived to adulthood in the Ice Age, one of the least forgiving environments mammals have ever faced. Somebody was sharing the kills. Care, after all, leaves no direct fossil. Nobody will ever dig up a shared meal or a defended packmate. The only place behavior like that can leave a mark is in its consequences, in an animal that should have died young and inexplicably did not. A ruined hip bone in a drawer in Los Angeles may be the closest thing we have to fossilized generosity. So there is the file. 5 patients. A trilobite that had its eye torn open by the deadliest hunter in its ocean rebuilt that eye and left its healed armor behind like a note that says, "I made it." An Allosaurus that absorbed 19 injuries across a violent Jurassic life and was finally brought down not by a rival, but by an infection in a toe. A duck-billed dinosaur that survived the bite of Tyrannosaurus rex and carried the king's own tooth, sealed in healing bone. A signed confession that settled a scientific war. A 6-ton Triceratops that took a rival's horn through the frill and spent 6 months healing, proving under a microscope that those legendary duels really happened. And a saber-toothed cat born with a ruined hip that reached adulthood anyway, hinting that the Ice Age's most infamous killer may also have known how to care for its own. Every one of these discoveries came from damage. Predation rates, ancient immune systems, pack behavior, combat, maybe even compassion, none of that knowledge came from the flawless museum lobby skeletons. Pristine bones can tell you what an animal was, only the broken ones tell you what it endured. what it fought, what it healed from, and who, possibly, was standing beside it while it did. That is the true ledger of paleopathology. The injury in one column, the tooth, the horn, the germ, the failed hip, and in the other column, the answer the body wrote back. The worst injuries in the fossil record are not a catalogue of death. They are the best evidence we have of life refusing to quit. 500 million years of it. Patched, scarred, limping, and still going. Somewhere in a museum drawer tonight, there is another lump of misshapen bone waiting for its scan, and another survival story sealed inside it. We will be here when they open the drawer. And if deep time is your thing, stick around, because this channel keeps a long line of patients still waiting for their turn.